Let's look at a worked example for delay guarantees. Two end hosts are separated by 3 routers and 4 250-kilometer links running at 100 megabits per second. The end hosts want to send a flow of 1500 byte packets to each other at 15 megabits per second, but they don't want their packets to take more than 10 milliseconds to go from end to end. If each router serves the flow at 15 megabits per second, how long will packets be laid in each router? We can assume a propagation speed of 2 times 10 to the 8 meters per second, and that the queuing delay is evenly distributed among the routers. From the question, we know that 1/3 of the queuing delay will be in each of the routers. So first, we need to figure out what the queuing delay is. The queuing delay will be the total delay, which is 10 milliseconds, minus the fixed delay, which is the sum of the packetization delay and the propagation delay. So let's first calculate the packetization delay, which is the time to transmit a 1500 byte packet onto each of the 4 links along the path. For each link, the packetization delay is 1500 bytes times 8 bits per byte divided by 100 megabits per second, or 10 to the power of 8. This gives us a total packetization delay of 0.48 milliseconds. Now let's calculate the propagation delay, which is the time taken for 1 bit to traverse all 4 links. The time for each link is 250 kilometers times 1000 meters per kilometer divided by the speed of propagation. The total time will be 5 milliseconds across all 4 links. So our total fixed delay is therefore 5.48 milliseconds. This means the queuing delay is 10 minus 5.48 equals 4.52 milliseconds, which we are told is divided equally among the 3 routers. Therefore, the queuing delay in each router can be no more than 1.507 milliseconds. The answer is therefore 1.507 milliseconds of delay per router. We could go on and calculate the amount of buffering needed in each router to hold 1.507 milliseconds of data. Given that the queue is being served at 15 megabits per second, this corresponds to 1.507 milliseconds times 15 megabits per second, which is 22,605 bits. In practice, we'd round this up to at least 2 packets, which is 24,000 bits per router.